Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is a cyclohexadienyl methanol. Specifically, the structure shown is a cyclohexa 2,4-diene-1-vial carbinol, i.e., 2,4-cyclohexadiene-1-vial methanol, which has a CH2 OH group attached to a non-aromatic cyclohexadiene ring. Moving on to the next step. Under acid H+ and heat delta, the alcohol undergoes dehydration. The OH is protonated and water leaves to form a carbocation, or the reaction proceeds to give a conjugated diene with an exocyclic methylene group. The product, A, is a methylene cyclohexadiene, specifically 1-methylene 2,4-cyclohexadiene, option a structure formed by elimination of water giving an exocyclic alkene. Moving on to the next step. A, which is 1-methylene 2,4-cyclohexadiene, also known as fulvene type, or more precisely it is the non-aromatic isomer, undergoes isomerization on heating. The isomerization involves a 1,5-H shift or acid-catalyzed proton migration that shifts the exocyclic double bond into the ring system. 1-methylene 2,4-cyclohexadiene can isomerase to toluene, methylbenzene, because toluene is the aromatic, thermodynamically most stable isomer with the same molecular formula C7H8. The driving force is aromatization, gaining the large resonance stabilization energy of the benzene ring. And for the final step, A is compound A itself, not B. C is another non-aromatic diene isomer, less stable than toluene. D, phenol, C6H5O, has a different molecular formula, C6H6O versus C7H8, and cannot be formed from this isomerization. The thermodynamically driven isomerization of the non-aromatic C7H8 isomer, A, gives toluene, B, the fully aromatic and most stable C7H8 isomer. Therefore, the correct answer is B. Therefore, the correct answer is option B.